So how do you determine the spring properties of a material? That is done with the standard tensile test, where you take a piece of material, you clamp it at both ends, and slowly pull it apart. Now, during this test, you would measure constantly the force generated and the amount of stretch in the material. Now, the problem with this method is you get a nice force deflection curve, but for a given material, that curve would look different depending on the size of the sample. For example, 1 centimeter diameter might give you a certain force, but if you test that same material in a 2 centimeter diameter, you're going to get 4 times the force for a given deflection. So in material science, we'd like to normalize this by converting the force and deflection into stress and strain. In a simple tensile test, stress is nothing more than the force divided by the cross-sectional area. Strain is also a non-dimensional unit, which is simply the change in length divided by the original length. Now, once you get this data, you plot this on what's called a stress-strain curve. The elastic modulus, which is the slope in the first section of the stress-strain curve where the stress and strain are nicely linearly proportional to each other. These have some other key points on the curve. Point A is what's called the proportional limit, which is the highest stress level at which stress and strain are linearly proportional to each other. Point D is the elastic limit. That is the highest stress the material can withstand before it starts to permanently deform and not go back to its original shape. Now, point B is what's called the yield strength, and this is the number that's reported on every data sheet. Yeah, the elastic limit might be a little bit more useful information, but it's a very difficult property to measure, while the yield strength is extremely easy and can be done in a split second. This is simply defined as the highest stress level that gives you a given permanent deformation. Usually it's about 0.2% permanent strain. Other points of interest on the curve would be point C, which is the tensile strength, or the highest stress level attained during the entire test. Then point X would be where the sample breaks. So if you're working with the socket contacts, you want to make sure your stress is somewhere over here in the elastic region.